Hello students, welcome to the next lecture on the measure of the dispersion. Today I will explain you the concept behind the quartile deviations. Myself Dr. Harish, you can follow and subscribe my YouTube channel. What we have discussed so far, we have learned the concept of the measure of dispersions which are classified into the two categories, absolute and the relative measure. Under the name of the absolute, we are defining the 5 different measures. For more details about that, you can watch my playlist Probability and Statistics. You can see the lecture of measure of dispersions. Also, you can see the second lecture, that is a range and the coefficient of the range about this first part. Now today I will explain you the concept behind the quartile deviations. But before I directly start with the quartile deviations, definitely many of the students will think that why there is a need of the another measure. If we already know how we can calculate the range, then why the quartile deviations needed? So consider the marks obtained by some students. Fine. Say the students A and the students B. If you calculate the range, what is the range of the first students? 50 minus 40, 10, 40. What is the range of the second students? 100 minus 10, that is 90. And you can clearly say the range has a huge difference. Fine. Why there is a huge difference? The difference is basically of this one information. Fine. इसके 50 के मुकाबले में 100 is a very large number and that large number I call as the extreme value. Fine. एक्सट्रीम वैल्यू का बच्चों पहले मैं पूरे लेक्चर में एक्सट्रीम वैल्यू काफी बार यूज करूंगा. एक्सट्रीम वैल्यू का मतलब ये नहीं कि लास्ट वाली वैल्यू. अगर आपके पास इंफॉर्मेशन है लाइक ऑफ 19, तो अगर मैं एक नंबर लिख देता हूं 1000, so 1000 is a very far away from the remaining of the number and that is called as the extreme value. Similarly, if I write the number is 0.10 and clearly say 0.10 is also very far away from the remaining number, that means 0.10 is also called as the extreme values, or I can call also as the outlier. Fine. Now as you can see, the difference is due to these extreme observations. So can you say the ranges are increases dramatically when you change only the one informations from the 50 to 100? That means the extreme value play a significant role while calculating the range. Fine. Now if I ask you, should the single extreme value determine the entire measure of the dispersions? Answer is definitely not. Fine. Why? Because if I just remove this 100 and 50 observation, then you can see the range is both the cases are same. That means the single extreme value does not determine the entire dispersions. And in order to measure that, we are trying to learn the new concept which play a significant role on the extreme values. Fine. जब भी आपको डाटा सेट में एक्सट्रीम वैल्यू हो और आप मेजर ऑफ डिस्पर्शन निकालना चाहते हो, देन यू कैन ऑलवेज यूज एज द क्वार्टाइल डेविएशंस. तो इसी को हम पूरा डिटेल में समझेंगे इस लेक्चर के अंदर. व्हाट इज द सिग्निफिकेंस, व्हाट आर देयर मेरिट्स, अंडर व्हाट केस यू कैन कंप्यूट देम. Another example, suppose a teacher wants to know the performance of the classroom. Fine. And these are the marks obtained by the students. If you closely look about that, the two students, one student has a very less marks, the second student has obtained a very high marks. So what can you conclude about that? What can you say? If you calculate the range, that means the range is my 90 minus 5 is 85. तो रेंज का मतलब क्या है? डेविएशन जो है वो 85 के अराउंड है. बट यू कैन सी द मोस्ट ऑफ द इंफॉर्मेशन is very far away from the 85. Fine. So that means, can you say these two students, that is the outlier, that is the extreme values, these two students, very low marks and the very high marks, is determining the class variability? Answer is probably no. Why? Because these are my extreme observations. Because most of the students are fall under the category of 35 to 50. That means आपके टीचर का रोल क्या होगा उस पे? Because I consider the example of the teacher, and the teachers is more interested to know the performance of the middle group of the students. And to measure this middle group of the data, we are trying to study the concept of the quartile deviations. So quartile deviation is the measurement of the spread of the middle 50% of the informations. For example, so if I explain you with the introductions, consider the data which are writing in the ascending order, and we are dividing into the 4 different forms. The first 25 category, 50, 75 and 100. We all knows what is the 50% information, that is called as my median. The first 25 is called as the first quartile. Q1 is called as the first quartile. Fine. Quartile is also known as the 25 percentile. Similarly, the 75 is called as the Q3. Q3 is called as the third quartile, and the median is also known as the second quartile. Clear? The Q2 is called as the second quartile, Q1 is called as the first quartile, Q3 is called as the third quartiles. Now, if I ask you calculate the median of these information x1 up to the xn, fine, and clearly say this purple color is my median. Fine. Now look at the left informations, look at the right informations. If you calculate the median of the left of the information, जितनी भी आपके पास ये लेफ्ट डॉट बची यहां से लेके यहां तक, इसका आप मीडियन निकाल दोगे, दैट इज कॉल्ड एज द Q1. राइट हैंड साइड पे भी जो आपके पास ये जो डॉट्स एलिमेंट्स बचे, इसका मीडियन निकाल दोगे, दैट इज माई Q3. And that is the way you can compute as the quartiles Q1 and Q3. And you can clearly say we have clearly ignored the smallest and the largest value. And the interval Q1 and the Q3 is called as the interquartiles range, Q3 minus Q1. And this interval Q1 minus Q1 and Q3 contains the middle 50% of the informations. As you can see also in the data, आप देखो इस डाटा के अंदर अगर आपके पास ये मान लो पूरे 20 वैल्यूज हैं, तो देखो मोर देन 50% डाटा इसी में आ गया ना. 6 वैल्यूज तो बाहर निकली, 14 वैल्यूज के अंदर आ गई आपके पास. क्लियर? नाउ व्हाट इज द डेफिनेशन ऑफ द क्वार्टाइल डेविएशंस? सो फर्स्ट ऑफ ऑल क्वार्टाइल डेविएशन इज द हाफ ऑफ द, तो ये आपका रेंज क्या था, Q3 minus Q1, that is called as the interquartile range, IQR. If you consider half of them, that is called as the quartiles deviation. It is also called as the semi-interquartiles range. I know many of the students may think why divided by 2. Fine. So what is the definition of the quartile deviation? Quartile deviation is the measurement of the spread about the 50% of the information. So that means this is my 50% and the difference between them, that is the spread, ये तो spread होगा ना, that spread is called as the quartile deviation. Similarly on the right hand side, the 50% is my quartile deviation. Fine. The quartile deviation measure the spread of, so the total, और ये पूरा कितना आपका interquartiles range, Q3 minus Q1, and clearly say QD plus QD, twice of quartile deviation is nothing but my interquartile range. Therefore, quartile deviation is my interquartile range divided by 2. That's why we have used the divided by 2. But make sure students, if you are interested to find the coefficient of the quartiles, what is the meaning of the quartiles, coefficient of quartiles? Assume you have the informations, let's say x1, x2, x3, all are in my kg. Then if you find the Q1, that is also in terms of the kg. If you find the Q3, that is also in terms of the kg. Fine. That means अगर आप quartile deviation निकालोगे, that is also in terms of the kg. That means it has a particular unit. Fine. And whenever you have a unit, that is called as the absolute measure of the dispersion. Starting में मैंने 2 category define करी थी ना आपके लिए, absolute measure and the relative measure. So quartile deviation is a part of the absolute measure. On the other hand, if I consider the second data set y1, y2, y3, these are all in my centimeters. Then if you calculate the Q1, that is also in terms of centimeter, Q3 that is also in terms of the centimeter. So can you compare these two data set? Can you compare these two data set? Definitely not. Why? Because when you can compare the two data set if they are same dimension, तभी तो आप कंपेयर कर सकते हो. Either both are in the centimeters or both are in the kgs, और अगर सेम डायमेंशन नहीं है, और दैट मीन्स इफ दे आर डायमेंशनलेस. फाइन. अगर दोनों का डायमेंशन ही ना हो, then you can easily compare them. And whenever we are looking for the dimensionless quantity, that means we are called for the relative measures. Fine. And since we are measuring the dispersions, that's why we called this relative measure of the dispersion. जैसा मैंने कहा स्टार्टिंग में मैंने दो कैटेगरी डिफाइन करी थी, वन इज द एब्सोल्यूट एंड सेकंड इज द रिलेटिव, एंड द कोफिशिएंट ऑफ द क्वार्टाइल मेजर is a part of the relative measures. Fine. So the formula for the relative measure is Q3 minus Q1 divided by Q3 plus Q1, and clearly say this coefficient is my dimensionless quantity. Fine. And since once you can calculate the coefficient of the quartile measure for the data set A and the data set B, and since we need a dispersion, less dispersion implies more stability. Fine. And if you calculate the coefficient of the quartile deviation for the A and B, in दोनों में से जिसका कम होगा that is the more stable one. Fine. So the coefficient of the quartile deviation is used for comparing the two different data sets. As I tell you, it is purely a dimensionless quantity. For example, so can you calculate the median? What is the median of these 9 numbers? Clearly say the median is my 5. Fine. The remaining numbers, can you calculate the median of the remaining numbers? 1, 2, 3, 4. Clearly say the median will be 2 plus 3 divided by 2, and that is my Q1, first quartile. Can you calculate the median of the right hand side? The median of the right hand side is 7 plus 8 divided by 2, and that is my quartile 3. Fine. And once you know the Q3 and the Q1, you can calculate the interquartile range, which is defined as Q3 minus Q1, that is a 5 is the right answer. Similarly, if you want to calculate the quartile deviation, that will be Q3 minus Q1 divided by 2, which comes to be 2.5. Whatsoever the units of this data set, the same units will be occurring for the interquartile range and the quartile deviations. And if you want to find the coefficient of the quartile deviations, so how you can calculate? Q3 minus Q1 divided by Q3 plus Q1, that comes to be 0.5. Now the question is why there is a need of the quartiles deviations. Quartile deviation is a very important. It is resistance to the outlier. So can you find the outlier? Clearly say the 500 is my outlier, because 500 is a very far away from the remaining numbers. Fine. So if I calculate the range of the data set 1 is come to be 40. Range of the data set 2, 500 minus 10 is a 490, and you can see it is a drastically change. This change is occurring due to this outlier, or called as the extreme value. However, the quartile deviation changes very little, and hence it is a robustic. It is a very useful in terms of the skewness data, like of the income, wealth, house price, business, and so on. For example, suppose your income of the different peoples are 20,000, 5,000, 30,000, and so on, and the one income is my 10 crore. Clearly say this 10 crore is called as the outlier. Fine. Or you can call as the extreme value. Fine. And clearly say if you calculate the range or calculate the mean, that is my misleading to you. Fine. So therefore, if you skip this bilinear, fine, if you skip this bilinear, then you can calculate the quartiles deviation, and it is focused on the entire population. Similarly, if you want to buy a house which is on the sale, the prices of the houses are 20 lakh, 25 and up to the 10 crore, and clearly say that 10 crore is my outlier. Fine. Or if I say it is only the 5k, the 5k is also my outlier. Fine. So that is a very cheap house and that is a very luxury house. Fine. And in that case, the one luxury house should not discount the measure of the variability. That means the quartile deviation is not influenced by the luxury or by the cheapest house. That means you can easily skip this and find the quartile deviation to measure the dispersion's coefficients. Similarly, if you look about the scores and clearly sees that the 200 is my outlier because the rest of the number is very far away from the 200. So that means the quartile deviation still represents the measurement of the performance of the batsmen by ignoring the one very high score. Box plots are also based on the quartiles. We already know that the center number is my median, the Q1 and Q2 are my quartiles, and the box plot, whenever you are doing the box plot analysis, they are also based on the quartiles. As I mentioned, you quartile deviations are used as the 50% of the informations, and it is widely used in the economics, box plots, and it is observement of the extreme values informations. What is the comparison between the other measures? So does the extreme value uses in the range? Of course it uses. Quartiles it can't use. Variance yes, and the standard deviation is also. Outlier are very sensitive on the ranges. Yes, it's very high. Fine. As I mentioned you, if you calculate last number is 50 and if the last number is my 500 and the starting number is my 10. So clearly say the ranges of the first number is 40 while for the second number is my 490, and this very large difference is based on the sensitivity of the outlier. Similarly, very less outlier for the quartile deviations and for the high for the variance and standard deviations. So what is the summary behind that? We have seen the ranges will tell us only about how far the information we have, while the quartile deviation will tell us how the spread from the 50% of the information. Or in a single one line, we can say the quartile deviation are the more robust and the more reliable informations. In our next class, we will see what are the various 10 plus numerical example, how we can compute the quartiles and the quartiles coefficients. If you are interested, let me know in the comment box. I will upload for you very soon. Till then, you can share this video with your friends, like and comment on the videos. Best of luck, students. Happy learning.